Good afternoon. I'm Chuck Dieter here at the Headwater Science Center in beautiful downtown and abnormally warm Bemidji, Minnesota. And today we're going to be talking about one of our exhibits on the exhibit floor, the bicycle gyroscope. As a matter of fact, when the Science Center was just getting started back in 1993, 1994, this is the first exhibit that we had. It took me a while, but I got this thing built and had to search it, had to design it and search for the parts and so forth. But we would take this around to things like county fairs and public events and so forth, and try to promote the idea of a science center and give people a chance to see what a hands-on exhibit would be like. So the bicycle gyroscope has been with us for a long time, and it's been a lot of fun for a lot of visitors. The basic idea of this is some basic concepts of physics. Now, when it gets to physics, I probably mentioned this before, but I'm not the best person to explain things about physics. I'm really fascinated by it, and I want to learn a lot more, but it's a little hard to describe some things because it gets pretty complicated. And, well, you can understand some basic ideas without having to get into the complicated math and some of the more sophisticated concepts. Anyway, with this one we can have a lot of fun. Now, this incorporates some things that probably have already seen, probably many times. For example, well, probably some things you've experienced on the playground. You might have had the experience of, well, I don't know if they do it anymore, but they used to have these kind of merry-go-round things on a playground where you could grab onto a handle and spin and spin and spin and spin and spin and spin. That's a lot of fun. Maybe you've taken well, a swing and twisted the ropes and twisted the ropes and twisted the ropes, and you're sitting in the swing and then let them go and you're spinning. Interesting things happen when things start to spin. Bicycle riding is probably the most common experience people have of these kind of principles. Remember when you were learning to ride a bicycle and you were afraid to go fast, you were afraid to get hurt, you were afraid that you're going to crash into something, and you start out very slow and you're kind of wobbly, but then when you finally get your courage up and you get moving faster, suddenly it smooths out and you find out, but my gosh, I can stay up, I can stay on these two wheels. Pretty fascinating. Well, fascinating, fun, physics. This is what we do with the bicycle gyroscope here. We ask people to get on this spinning disc. There's a disc down here that spins very freely. And I took a long time trying to find the bearing that would go under here. And searching a lot of junkyards, I finally found a nice rear wheel bearing from an '83 Buick. And that's what's been spinning in this for 24, 25 years. Still going, still holding up pretty well. So what you do, the first thing we usually ask people to do is to, you know what? Let's have somebody do this. Volunteer. Come on up. Tell the people their name.
I'm Z.
You're Z?
Yeah.
Step right up, Z. Okay, so the best way to do this is to have all of your weight directly over the center of rotation. That kind of makes things more efficient that way. Now, when people get on the bicycle gyroscope disc, what they like to do is this. Don't do that. Also, they like to look at their feet. I think that makes you dizzy, so I usually tell people look straight ahead, stand as straight as you can, like you're made out of concrete, okay? Now, you've probably seen this before, looking at figure skating competition in the Olympics or something like this, and it really is kind of fascinating, but what you do, hold your arms out straight. Not straight, out, far as they'll go, okay? I'm gonna give you a little rate of rotation. Have you done this before?
I think so.
You have done this before. Then you're a pro, you know how to do it. Okay, here we go. I'm gonna give you a little rate of rotation. Here you go. Now pull your arms in like that. And notice the difference. And then put them back out. Everybody see that? Pull them in. And your rate of rotation increases. And you put them back out. Pretty cool. Ta-da! Very good. Now, when you experience that, I don't know if you had fun, but I think it was kind of fun.
I had fun.
I think it's fun to do that. Now, another thing you can do with this is use the bicycle wheel. Now this feels kind of magical, although if you've ever ridden a bicycle, you've already experienced this. And, well, if you've ever spun anything on a string or anything like that, you've already experienced this. But, step right in the middle again. I'm going to spin the wheel. I'm going to try to spin it really fast, and I'm going to hand it to you. What you do is hold it straight out like this, and then tip it over to the side. You could start like this, and then go upside down, but that might be a little too fast, okay? So, start like that, stay still. All right, now, you're not moving. No, wait. Just right there. You're not moving, right? You're standing still, everything's the same. No net motion, no net momentum in any direction. Turn the wheel. Ta-da! And it's the motion of the wheel, the energy in the wheel that's actually turning your entire self. Now go back to the starting position and you stop. Turn the other direction. You're in control. Ta-da! Very good. Let's have a hand for Z.
Thank you.
Yay! Now the physics that's involved here is a little, well, it's pretty complicated as a matter of fact. Here's a couple of things to think about though. I don't know if you've ever noticed it, but when you're spinning something on a string, and you let go, it may kind of arc a little bit because it goes up and then it comes down because gravity pulls it down. But when it first starts traveling after you release it, it goes in a straight line. Here's something to think about. Right here, which direction is this thing moving? At any given point on the circumference of this circle, right here, the direction isn't in a curved line. It's in a straight line, that way. Here, it's spinning like this, straight line that way, that way, that way, that way. That's something to think about. And in another thing to think about is, let's see, how can I explain this? It doesn't seem like it, but if you go online and just put in bicycle gyroscope, you'll get lots of interesting explanations. One of the things that they emphasize is something called the right-hand rule. Now, it doesn't seem, you can't really get this by feeling it so much, but when you spin, say, got an object spinning in this direction, you take your right hand and you curl your fingers in the direction of rotation of this object as if you're going to grab the axle. Grab the point of the axle around which it's rotating. If you extend your thumb, that tells you that there's a component of angular momentum that is in line with the axle, extending that way. Now that's a little hard to grasp, a little hard for me to grasp too, but yours is spinning this way, and I know that here, there's a component of momentum going straight that way. It's true. Plus, you've got all these things going. Now, if I turn it, Newton's first law says that things tend to stay in their inertial state. That means if something isn't moving, it tends to stay not moving. If something starts to move, it tends to move indefinitely. Newton's third law states that for every, usually it's expressed by saying, for every action there's an equal and opposite reaction. Now, this is oriented this way. If I change the orientation of the axle, I have to push against it, and it resists my motion. And you can feel that, but you can feel that, Z. When you turn it, you can feel it pushing on one hand, pulling on the other, and that's what turns you.
Yeah, my wrist got kind of sore.
Your wrist got kind of sore. And that is a very brief and not quite complete explanation of what's going on. But if you come to the Science Center and you try it, you'll feel it. And if you're riding a bicycle, you can feel it. Because once you start getting up your speed when you're learning to ride a bicycle, you can tell that that axle is in its position, because when you start to tilt, when you're going to lose your balance and fall over, it resists motion. The axle starts to tilt this way, but it pushes back against the tilt. Start this way, pushes back against the tilt, pushing you back into the center. So the faster you're going, the more stable you are. Now, I've seen some guys on the freeway riding motorcycles. They're kind of scary and not riding very safely, but they can go way over because they're really going fast and not tip because the axles are pushing back to the center, pushing back to an upright position. You've probably already seen that too. And there are all kinds of ways that this is expressed through things, you know, in our daily lives. When you're in a car, that's an effect that happens with all four wheels. That gets some really complex physics, really complex science of pushes and pulls. Anybody else want to give it a try? Tell you what, come on up. It's nice to have volunteers here because we can just kind of say, come on up, and they do it. Put your feet right in the center, right together, right in the middle. Now, one thing we do is challenge people on this. Now, you've probably done this before, right?
Yeah, I've done this.
You hold it out like this and you tilt it. Okay, let's go through that. Just hold it out like that and tilt. There you go. Now, you get the best spin if you're nice and flat. And then stop. Go back to tilt the other way. Now, you're so experienced that that's not too exciting. But I'm going to hand it to you like this, and I want you to turn it upside down. Okay? I don't know how you're going to turn that hand over, but you can try it. And turn. More fun! Absolutely more fun! And go back to halfway. There you go. If you go back to halfway, you go half speed. But now you go back to the original position. Ta-da!
It's actually fun.
It is actually fun. All right, thanks. Now here's one more thing I want to show you, which is kind of mysterious. And, you know, sometimes if you go on a website that has to do with something like a bicycle gyroscope, they'll show you this, and then they'll give you this not very satisfying explanation that this is probably too complex for you to understand if you haven't been a physics student for a couple of years. But this is kind of fun. If I just hold my finger like this, like a hook, and I put this on, you know, put the handle or the grip on my finger like this, and I let go with this hand, of course it falls. Gravity's going to pull it down. But if I spin it and do the same thing, it does not fall. Magically. Well, not magically, scientifically. It stays up, does not fall, and turns itself in a circle. Now that process of turning in a circle is called precession, and that's something that has a profound effect on every plane that has a rotating propeller. All kinds of rotating things, machines that have any kind of rotating part, have to take that effect into account. And the machine has to be designed to withstand the forces that are involved. Now the forces get kind of complicated. It involves the rotational directions of force, and it involves the support on one end, and it involves gravity pulling down on the other end. And when you mix all of those are often diagrammed in something called vectors. If you diagram all the vectors together and do it accurately and measure it accurately, you can get a pretty good idea of why that happens. But it's the reason that helicopters have tail rotors. You know, you wouldn't want a helicopter or a single-engine plane to go spinning in the sky like this, which would happen if you didn't have some way to compensate for it. Either a flywheel that kind of rotates, or some aerodynamic design that prevents things from taking over and sending you out of control. Anyway, this exhibit can be simple, and you can have a lot of fun just spinning, just putting your arms out and pulling your arms in, feeling that physics firsthand. Or, you really want to get into it, you can get into some pretty heavy physics and do the math. But that's a pretty good explanation of the bicycle gyroscope. We've got lots of other exhibits here at the Science Center. They're hands-on exhibits that we can talk about. If you want to just play with them and get the fun out of it. But if you want to talk about the science and even delve into the math a little bit, we're here for you. Just ask a question. Please, ask questions. We love questions.